Hello,
Gary?
hi Rita.
Hi, everybody.
Hello, guys.
So we have full comment here, and let's start. Last week I was still working on the military implementation and added the merge support, and I think it's basically the functionality wise it's okay, and I'm trying to add more unit tests, and later on I will adapt it to based on Sam's LBA tree implementation to rewrite the mutation and the duplication and the allocation and release them with LBA tree based implementation. That's my plan. And I said from it, I still reviewing PRs. And by the way, today I would like to discuss the PR of 34492. I'm posting CUR in the chat window. It's related to how to do the graceful shutdown after the meeting. And that's me, Chunmei.
Not much updated. I just doing the extend map tree code.
We lost your voice.
Yes, I
sorry. Not much updated, and I just doing the extend map tree coding and define the extend map manager interface, and we'll do the B tree coding. So that's all.
Are you start from scratch regarding to the B tree implementation?
Yeah, I'm going to implement the B tree.
Okay.
I think it's similar as LBA tree. It's fixed key and
yes.
So
structure
is
that's why I asked.
The structure is simple and just like LBA tree. So yeah, so that's my work.
Okay.
Sam, you said something?
I said, yeah, it should be similar. There are some utility classes in there you might be able to borrow. Unclear. Can you guys hear me?
Yes,
okay.
Now we do.
Yep, we can hear you.
Redek.
Okay. Backfill. Yesterday, Crimson has pushed its first object to replicas, and also switched to the backfill state. I mean, it successfully went to the active and clean. Right now, I'm cleaning up the branch, implementing some minor missed functionality, like, let's say, sending the information about backfill process. I mean, operations like I will post in the chat. Also, I'm rebasing the branch to master, which is a bit cumbersome because I'm based on the pretty old version of the recovery branch, and since then a lot of things have been moved across the project. I need to catch up. Besides of that, I was reviewing engine and Szechuan PR for shutdown. It looks sane. This very small thing maybe that we should decouple the change related to our YAML and CBT performance testing from the C++ changes. I've got impression that the first commit will need a little bit more discussion. But anyway, it's good. It's a step in good direction, I believe. That's me.
Were you talking, Kifu?
Say it again, sorry.
Did you try to say anything?
No, I'm
No.
trying.
Okay.
I think it's your turn to share your progress.
Okay. Yeah. I was mostly reading code, trying to. Do you hear me? Okay. I'm still fighting my microphone.
Yes, it's just looks funny, like you are wearing a mask. Do you?
Exactly.
Yeah, I have. I have.
Okay.
One second. Let me move out of the sun.
Much better.
Yeah. Okay. I'm trying to find a point where I don't have the sun in my eyes anymore.
A mask made from the light.
Yeah. Okay, let's leave poetry now and back to back to Crimson. I'm apart from reading PRs, I'm trying. What I'm doing is mostly reading code to understand the services I should use when actually moving the state machine code I have to Crimson environment. So this is more or less where I am. And I will be probably interacting directly with people asking questions about services and the usage, infrastructure and its usage. That's me.
Hey, Sam.
Yep. I addressed the first round of comments on the first PR and pushed a copy. Kifu, I think you still wanted to look at the cache logic.
Yeah.
Anyway, so I'm waiting on that phase. No particular hurry.
Okay.
I have unit tests that now successfully split nodes, and I'm now working on the incref and decref logic that involves removing LBA mappings. That's it.
So Sam, I just want to make sure that it's quite ready regarding to implement ownership based on your LBA tree, right?
I mean, not really. But it still can't actually decrement the ref counts on nodes. But the transaction manager interface looks right, so that's what you'll be using. You know what I mean, right? I haven't changed anything in the transaction manager interface in like 2 months. So that seems pretty stable.
Okay. That's what I'm asking. Just make sure the transaction interface is stabilized and I can program based on it.
I mean, it shouldn't be overly complicated, right? The only things that really gives you the ability to do are mutate a block and create a new block and get rid of a block. In that sense, it's not a huge assumption, right?
Yes. I just wanted to make sure I can start to experimenting the ownership implementation based on your implementation, so I don't run into some strange behavior.
Oh, I mean, it'll crash because
debugging LBA tree. Yes.
It'll crash because it's not implemented yet, or a lot of things aren't implemented yet. But
okay,
that's what I'm saying. The interface is present, but a lot of it's not done yet. If you take a look at the current branch, the transaction manager has one unit test. That's pretty much the only thing that works. If you extrapolate out to the LBA manager, you can guess that you could probably allocate a lot of things. You just can't decrement ref counts at the moment. I expect to have that this week, though.
Okay. So I will
That is,
focus
you might
on
have to
the
comment out the code for releasing a block, but that's different. You can overwrite them though.
So I can live with the memory leaks. So
Yeah,
if,
well, in
if
this case,
that's
it's a
okay.
space leak, but it's just as well because everything's a space leak because it can't clean segments either.
Okay, I see.
Yeah.
Thank you. Johan.
Last week I spent most of the time modifying the clean shutdown PR, and I also spent some time developing a blocking IOs for recovery ops, and that's all for me.
Yeah, for the ONO tree prototype, two things are implemented: the block layout with index deduplication and the lookup inside all types of the nodes, and they are highly coupled with each other. So I want to make this stable first, and the second part is a recursive lookup in the tree down to the leaf, also with all types of nodes are also implemented. And in this version, I tried to minimize the unnecessary lookup efforts, including to minimize the full string compare effort. So the next step is to implement insert and node split based on the current work. That's me.
I'm trying to understand what you mean. You mean you try to minimize the string lookup? Is this covered by SeaStor or it's an improvement based on it?
Samuel's document doesn't show how to implement it. It just
okay.
Right. So it is a way to implement those to minimize the string compare, but I think it's complied to Samuel's design.
Okay. Are you just talking about the part where you omit the string for sub nodes where it's the same? Is that what you're talking about?
Yeah.
Yeah, that's fine. Okay.
Yeah, and your document doesn't.
Well, it says just that.
Clear how to implement that.
It just says omit the tuple elements that are common.
Mm-hmm.
You already know what they are, right? So if the level N1 is defined as not having the first three tuple elements, then you just remember those three when you begin reading that node. You know what they are because you descended to that node in the first place.
Yes.
Right? Yeah, that's it.
Okay, so to my understanding, it's already covered by SAM, but it omits the implementing details.
Hey, Kifu, just so you know, if you need a functioning transaction manager before I have one, feel free to create or to interface out transaction manager and write a stupid in-memory implementation. It'll be useful for unit tests anyway. The semantics should be pretty obvious, right?
Yes, I can do that.
It just gives you the ability to like allocate a new block or mutate an existing one or release one. That's kind of it.
Yes, I think it's actually will be very useful in long term or midterm.
Yeah, I mean, this is I tried to make it as modular as possible so that we don't have to actually mount disks to test these components. We want to be able to exhaustively test the B-tree stuff without starting up a single SeaStor instance. Okay. And then we'll start up a SeaStor instance that tests it even more. But that way we'll see test failures at like a really particular component and not just SeaStor crashed.
Indeed. I just want to make sure the failures are isolated so we don't try to complain each other.
Well, and that's true. If the semantics of the transaction manager change, then yes, that will be knock-on work. And that's just risk we're adopting by doing these things in parallel. But I don't think it's that risky.
Okay. I see. Thank you. So I think before concluding the meeting, I'd like to have a short discussion regarding to how we should do the grid-flow shutdown. I'm posting the URL in the chat window. So there's a so currently, Xuan, could you walk us through the PR to denote the general idea of how we want to attack this problem and what the problem is?
Okay.
Thank you.
I think the basic idea is that since the messenger is already tracking all the ongoing continuations by guarding them with a gate, and I thought we can do the graceful shutdown by 2 or 3 steps, and first of which is to prevent any further event processing by adding a stopping flag, or as Yingxin suggested, we can unregister the dispatchers from the messengers. And the second step is to interrupt all the ongoing event processing by setting all the necessary promises within a shutdown exception, and then we wait for this should be done. This is done in the messenger, which is to wait for all the continuations or all the event consumptions to finish, and then we can clean up all the things. And this is the basic idea. And I think the main discussion should be around the idea that to release messengers from the job to track all the ongoing event consumptions, and letting each component to do that themselves. Is that right?
Yes, I think I'm on board with you regarding to
yes.
to removing the dispatcher by itself when it's trying to, it's notified to start shutdown, and then the messenger want to dispatch more events to them before it is removed from the chain dispatcher registered by into the messenger. And later on, messenger will start to tear down. If we are fine with this approach, it's fine. Otherwise, please raise your hand.
I think the current graceful shutdown implementation is a little complicated because message ability to track all the ongoing events for the event dispatching, and actually it is implemented in the higher level components. So when each component shut down, it needs to distinguish. So it doesn't care its event consumption futures, but it still need to implement a gate to if there are some other internal continuations in the component. So that's why I think if the messenger can be decoupled with to track the event consumption futures, then the entire shutdown procedure can be much simpler, but it can be in the future iterations.
Let me just, I just read your comment.
Yeah, that's basically what I said.
Okay.
In the comment.
What I'm trying to understand, it would still be the messenger responsibility to handle throttling, right?
Yeah. Yes, of course. If the connection needs to be throttled, it must be notified from some interface. For example, the MS dispatch to return futures to throttle the connection. That should be done in certain ways.
Okay, but the decision is probably relegated to the components, specific components.
Sorry.
What
Okay, never mind.
decision?
I want to read the code to see that I'm not talking. But the specific decisions regarding when to throttle are probably components.
Yeah, I think so. It's depend on the component decision.
I think the decision is predefined, pre-configured by the throttling policy when we construct the messenger. It's not the call of a consumer of the messenger, right?
I think that's a different way, maybe. So if throttling is configured in the configuration, so it is static. So the throttling is static, right?
No, not really.
But,
we can change it on the fly. But
yeah,
one thing is that throttling is managed by messenger instead of by the component, which consumes the messenger.
But the messenger doesn't know if the component is overwhelmed with messages. So we need to tune that configuration to address that. That's less flexible. But if component knows that it is overwhelmed and throttle the connection, then we doesn't need to configure that, right?
Okay, I'm trying to understand what you mean. If by overwhelmed, you mean the underlying the messenger is pumping up too many or too
yeah. Yes.
Too many messages even to be consumed by for example, OSD or PG, and so
yes.
you will want to give the flexibility of the PG or OSD to push back to messenger if it's heavily hammered by the.
Exactly. That was what I think we should formalize.
So imagine there's a queue between the messenger and the OSD. The messenger continues to push messages into that queue to be consumed by OSD. When OSD doesn't able to consume at certain rate, the queue is filled. Then reversely, the messenger should be understand that and slow down.
I see what you mean.
So it's the same idea to return the future in MS dispatch, I think. But it's just currently just a dummy future.
That makes sense. We could have a semaphore which is controlled by semaphore, but the dispatcher and the future, though, is a straightforward way to go to implement the throttling. I think. Yes.
Yeah, but that's it's a different thing to the graceful shutdown. So
yes, it's orthogonal.
So what I mean is that if some dispatching doesn't need throttling, so messenger might so those interface might just return void to the messenger.
Yes. So if there's no objections, we can go this way as an input.
But that needs some more efforts in each component, I think.
I have no problem with that.
Okay. Any further questions at this or questions?
One last thing is that whether we should use a stopping flag to indicate where actually shutting down the OSD, or should we unregister the dispatchers from messengers
to
prevent further execution?
For unregistered approach, because it's it's distracting to check the spotting flag when we are going to do something. That's what I'm saying, I think.
Then I have a problem about which data structure should be used to hold those dispatchers, and because I've tried several ones and all of which are problematic.
Single list. I think that's the way to
go. I tried intrusive list, not single list. I tried intrusive list, but it also triggered some exceptions. I don't recall the specific ones, but it definitely is also problematic.
Okay, probably we can discuss it offline and try to figure out what's the right way to remove a dispatcher from the chain dispatcher.
Okay.
Any other questions? Okay, talk later. A good one. Thank you.
Thank you.
Thank you, and see you later. Bye.